Deployable.
So he's going to give a quick overview, and then we have a panel of assorted experts from assorted places. Over to you, Ignas.
Thank you. Good afternoon, colleagues. So from one really good thing, I mean Finnish smoothie, to another really good thing, aspects of BGP, and in particular the security of BGP. BGPsec. What's that? What to do about it? Do we need to care? If we do, how do we care about that? And what can be done of trying to make this thingy deployable? So first, about a few perceptions in the community, in the industry overall about BGPsec. And those perceptions don't necessarily show it in a very positive light. That BGPsec is, well, first thing is questionable whether such thing exists at all, except of some academic vision or science fiction. Whether it can work at all at some reasonable scale, not even necessary about in a global network scale. If it can, whether the performance is sufficiently enough to make it work practical. It probably has associated costs that you need to replace all your shiny kit which you deployed just recently. And then we have substantial amount of experience with origin validation. Maybe there's a valid question that origin validation is enough for securing BGP. Maybe we need to raise a question that, well, we think that BGP is secure anyway. Do we need to do anything at all? What about the scalability aspects? What about leaking and showing off the information which is not necessarily supposed to be visible? And that's a change to the regular BGP operation model. Is this a real problem? Does that address what is something painful in the field and worth addressing that instead of ignoring? And complexities related to the operation of the cryptographical systems, the key management mostly. So in summary, all of this puts BGPsec in a context that does not help for it to get, say, a positive image. Let's take a slightly deeper look into that. So together with my fellow colleagues here on the panel, Job, Frederick, Alessandro, and Juhani will try to look into some of these aspects. What I would like to ask from my side is that the format of this discussion is not only us spreading the propaganda here from the stage, but that is bi-directional communication here. If you have something to say, you disagree with something, you have questions, the topics discussed seem too controversial, please come to the microphone over here and discuss that without waiting for the end of the presentation. This way, this will allow us for more interactive discussion. And please really do that. So with this, I'd like to start with, I'd like to ask Frederick to tell a horror story.
Yeah, sure, love to. Okay, so yeah, I'm Frederick from AWS, work with Edge Strategy for our company. So I want to start out with like a hypothetical or maybe not hypothetical horror story of what could happen or what might have already happened, right? Imagine like your country is at war with another country, and your country has a news website. Let's use nog.fi as an example here. And it's hosted in ASN, which the aggressive country may not like.
Can I speak into the microphone?
So the hosting ISP in this case has created RPKI ROAS, as you should do. You know, that's a very good, good job of the hosting ISP there to try to secure as much as possible. But the attacking country is trying to go around this, right? So they forge IRR entries in, for example, LTB or RADB to very common databases to put in information in IRR. The only real, hacker knowledge this person needs is to have an email address. That is the only resource you need to have available to create any garbage you want and put that into IRR databases. And typically how IRR works or IRR filtering works at big ISPs, that they maybe do a nightly job or like every other day they do a job to update filters. So what they can do here is they can pretend, if they have an ISP, they can put the destination of the attack behind them. Just as we heard from OpenFactor here before, that anyone can put in anything into any AS set, and it is really, really hard for anyone to detect this. It is very few companies, if even any, that does monitoring of this stuff. So it is basically a dark pool of information. And the attacker also maybe runs an ISP that has access and is customers of well-connected and large networks, maybe even international transits that spans the global internet. And they just wait for that ISP to make sure that their nightly filters update. So let's give them 3 or 4 days to kind of set the stage for the attack. The attacker then sends in the forged origin, so just forging the origin, just appending the ASN of whatever they're trying to attack. Because, as we said, the hosting party actually runs RPKI ROAS on everything, so they can't use their own ASN, so they need to actually use the correct ASN. So they do that. And the only thing that really controls if the attacker wins or not would be AS path length. But there is a trick around that too, and that is, unless you didn't want to steal the traffic, maybe you just wanted to kill it, then it is today very easy with any network to send in black hole communities, and that route will most likely be preferred over the actual original route. So this could happen, and what happens here is that basically all of that website is knocked out because it is black hole in very large ISP's network, and then the news on that website will not be able to reach the end user. Today, there is really no technology either the hosting party or the upstream could have implemented to make this go away. There is ideas about peer locking and stuff, and ASPA to some extent maybe could help, but it's not universal and it's not for everyone. So that's a little bit why I'm here on the panel today, because I want to see how we can actually do this good on a 10-year kind of type of plan. So the sentiment here is that ASPA wouldn't have helped, IRR certainly doesn't help, or rather the opposite way actually, and RPKI doesn't fulfill all the needs here because there's still hole in how we do BGP security today. That's the horror story. Are you scared yet?
Yeah, really scary. For the audience, is that scary enough to raise any questions? Probably no. Well, let's look then into a gentle introduction into the BGPsec mechanics and operation. So first thing, that's not a new BGP. That's an extension to the BGP that you are very well familiar with. And that extension deals with cryptographical verification of an AS path. The overall operational model is the same. AS path still works as it used to be, but together with the actual AS number sequences, it carries signatures of the previous hops over which it has traversed. This gives you a possibility to get an answer that after the validation, that the actual path that you see in the AS path in the update, whether it is forged or that's genuine. This works for extended BGP only. It has defined meaning for extended external BGP sessions only. Well, that's natural, because that's the only place that modifies the AS path. And transit nodes sign all of the received AS path and also sign the hop to which they will be advertising this update. So this gives the binding of the received path and the indicator to where to it has been sent. This way it prevents possible spoofing by putting into the signature the target AS number to which it is advertised. And then the receiving node can verify that it indeed was intended to be advertised to that receiver. The signature also covers the prefix. Today that is defined for IPv4 unicast and IPv6 unicast. Technically, this can be extended to other address families. But having a signature covering the prefix itself also allows you to bind the AS path to the prefix. It also has certain drawbacks. That means that you cannot send out one update for a block of prefixes which have the same set of attributes, because the signature will be unique to each and every prefix. This has certain resource cost. The signature itself is a traditional digital signature algorithm, crypto scheme based on asymmetric keys. So the router signing has a private key, which is a secret, and then the rest of the world has private keys, which can be used for verifying that signature. All of this machinery assumes and requires the underlying RPKI infrastructure for support. And data like keys and other objects which are required for this, they are kept in the RPKI infrastructure, in the RPKI database. The important misconception in the field is that BGPsec and RPKI are competing entities. No, they are not. They are complementing. You actually cannot meaningfully use BGPsec without an existing RPKI infrastructure with the required extensions for that. With this, it's time for another horror story. Job, can you tell us some of your experiences?
Another fun story. A few months ago, a famous cloud provider fell victim to a very interesting attack. Some of you may recognize the pattern where ISPs, technicians at ISPs register a domain name in the pattern as_a_number.net. Sometimes these domains are used to publish technical documentation that is too cumbersome to publish through the corporate website. So adversarial entities have picked up on this pattern and registered domain names associated with AS numbers of big cloud providers and put a few IR objects in stuff like RADB or LTB, not for the purpose of actually introducing route objects to subvert filtering, but to add legitimacy to these domain names and to show the other victims, sellers of IP transit, that the domain name was legitimate to some degree. These adversarial elements would then purchase transit ports from tier 1 providers, sending purchase orders from nog@as_fewdigits.net. And the crazy situation that then arises is that you have spoofed ASNs directly connected to tier 1 providers, and then hijacks start. And this causes an incredible amount of confusion for all parties involved. Because imagine that a large cloud provider has, say, 30, 40 ports with a given transit provider, and 2 of those ports end up at the spoofed entity. You have the correct origin, an incredibly short AS path, prefixes that you also see on other sessions. And this is a pain to debug and remedy. Now, BGPsec is a mechanism that would help prevent this type of attack, because even if you somehow manage to subvert the purchasing process and bypass the due diligence of the selling tier 1 provider, with BGPsec, an extra obstacle would be added to the chain, which means that you not just have to impersonate the AS and use the impersonated AS in the AS path, but also somehow obtain the private keys that are associated with that AS. And that would be such a high barrier that I believe that attacks like these, which are fairly complicated to execute, but not impossible. These things happen in the wild and have caused significant downtime or stealing of traffic. So this is why I'm interested in BGPsec. Where BGPsec already has use if the AS path is only one hop. You can use it to verify your direct adjacencies. And a nice architectural advantage of BGPsec is that it offers us a transitive trust capability. So if a network grows behind the one hop, the BGPsec signature change will extend into that growth, which I think will make BGPsec future-proof. So that's another horror story. People are really pretending to be entities they are not, and getting away with it to some degree.
Excellent, thank you. Any questions so far? Any comments? You have any horror stories from your side to share? Anything else? Well, hopefully everyone feels secure enough with the existing BGP. Maybe we don't need BGPsec at all then. Right. I would like to discuss, ask Alessandro to discuss a little bit from the other side, from a customer base, and specifically from the exchange operators' perspective. So can you tell us something about that?
Sure. But first of all, I'm Alessandro. I'm an engineer manager at Catchpoint.
And could you please speak to the microphone?
Sorry. Better? Any better? Okay, perfect. Sorry, I'm Alessandro. I'm engineering manager at Catchpoint. Well, just to corroborate what Job and Frederick were saying, back a couple of years ago, we did a presentation about hijacks and leaks. And we found out, for example, that on BGP Mon page, there were like hundreds and hundreds of different prefix hijacks every month. And even worse than that, we tried to categorize the victims of every of the hijacks. And not always they were the big providers or the big players in the world. Sometimes there were the small guys. Said that, back to my topic. Well, BGPsec mandates end-to-end operations, of course. To be safe, you have to have end-to-end operations, which is at the moment not really realistic. But the exchange points are, to me, in my opinion, they look like a very, very good starting point where to start implementing the BGPsec. Let me tell you a couple of things why that's so. For example, exchange points keep traffic local. And keeping traffic local and routing local means also that they become some kind of islands of routing. Of course, that's not always the thing for every exchange point, but I'm talking broadly here in Europe. This means that every exchange point has its own community, has its own ecosystem that is perfect for the incremental deployment of BGPsec. Well, and also having one specific ecosystem in an exchange point also means that any hijack or leak going on an exchange point is likely to never leave the exchange point at all. Meaning that if there is no route collector in BGP or in any the dedicated tool deployed by the exchange point on that location, well, the participants of the exchange points will never see the hijack going on, and there is no reaction to that, which is a bad thing and a pro in deploying something like BGPsec on the exchange points. Well, in addition to that, of course, at exchange points, the autonomous system paths are very, very small. Usually small, meaning that you cross just a couple of autonomous systems to get to the destination via an exchange point. Which means also in BGPsec realm that you are not going to apply as much cryptographic operations as in the default-free zone, meaning that it should be feasible to use it on exchange points, even though it's complicated on the rest of the internet. Well, it is my opinion at the moment that probably the gains that BGPsec would apply to exchange points, which is security, may at the moment outweigh at least the cost that it is incurring, which is a little delay required by cryptographic operations.
Yep, you have a comment?
Yeah, to add to that, as you may know, IX route servers hide their own AS number in the AS path attribute. This is advantageous because it helps mimic direct bilateral sessions between participants of the internet exchange, but it is terrible from a troubleshooting perspective because the route server is hiding itself. It's like a sort of black hole in the routing topology. The way BGPsec handles this particular case is very interesting. The AS path stays the same, the route server is not visible. The signature path, however, contains the signature of the route server. So with BGPsec, we maintain the advantage from a traffic engineering perspective, but we get full attribution that anybody connected to the route server is actually who they say they are, and that all AS numbers can be validated against public keys in the RPKI ecosystem. So BGPsec is a very elegant approach to the fairly complicated phenomena of route servers, which makes it a good starting point in my opinion. And then secondly, route servers tend to run on commodity hardware. So if computational overhead is a concern, you can deploy route servers on beefy computers that have modern Xeons with some cryptographic assist, which may also help overcome some deployment challenges. So route servers and BGPsec, in my mind, are a beautiful marriage.
All right, thank you, Alessandro. And Joban, I see a question.
Yeah, that reminds me of a question because when running route servers on some IXPs, you very often get asked, why are we receiving 0 prefixes from the route server? Which is usually because the default setting on routers is that these days, they match that the first AS in the path matches the neighbor's AS number. So now, the thing with BGPsec is that when routers start supporting it properly, I sort of don't foresee the case where they can ignore this check and at the same time make good BGPsec checks on the peer. How do you feel about how this sort of a problem should be fixed? Or if there is a good solution to this sort of problem?
Anyone wants to take all?
To summarize your question, you highlight that there is difficulty in provisioning sessions from an IX participant towards the route server because the route server is not the first ASN. The route server's ASN is not the first AS in the AS path, and this causes a bit of confusion, especially with newer networks. Is that capturing it? When we extend BGP implementations to support BGPsec in, say, BERT and OpenBGPD, but also in, hopefully, implementations like Arista BGP and others, I think it certainly is worthwhile to also take a look at a fairly new RFC called BGP Open Policy. And this is a RFC that describes that both sides of a session in the open message of the BGP session negotiate with each other what the expected role of the other side is. And from there we can maybe automate some of these checks and make the configuration less hard for newcomers. I don't really see a way around asking operators that if they set up a session with a route server that they configure something along the lines of this session is going to a route server, but it shouldn't require more than that one line, and I think there's a path available to us to achieve very minimal, simple, straightforward configuration to overcome the challenge that you described.
Further question. So does this new extension include non-traditional peer types in addition to internal and external neighbor, like confederation neighbor or route server, route reflector, things like that?
The BGP Open Policy RFC is for eBGP, and it describes roles like I am upstream, I am a customer, I'm a peer, I'm a route server, I'm a route server client. And there's a small table of which things can peer with each other. So for instance, if both sides configure themselves to be upstream, the session would not establish because that's considered an incorrect configuration. So if one side configures themselves to be upstream, the other side has to configure themselves as downstream. Or both sides have to configure themselves as peer, and so on.
Overrule me if you think this is out of scope, but have you seen traction among the vendors for implementations for this extension?
Yes.
Great.
Right, thanks for that. Any other exchange operators, do you have any experience to share, any research that you were doing, any other thoughts of this topic? I would be very curious to see show of hands if any of you were looking or thinking about these topics and whether you see BGPsec as something of potential future importance for you. Anyone? Somebody over there in the corner, right? Excellent. Right, so...
Go to the microphone.
Yes, and please share your experiences, even if there are very little, but you should not see us here at the front of the stage as some oracles who know everything about this topic. This is a new thing globally, and we are just starting to experiment with that.
So we are currently using Skyon on the Swiss exchanges. It's becoming mandatory for financial industry to run Skyon in Switzerland. Next version of Skyon will enforce that mandatory peering. So it's interesting for the financials now who peer in a lot of, not so much public exchanges, but definitely the financial exchanges to start looking at BGPsec and other types of things. Yeah.
Okay. Thank you. Any other interesting feedback from your experimentation or just thoughts? All right. Whenever we start talking about things related to important and critical infrastructure, various types of regulating authorities tend to get interested in this. And we have FCC looking quite actively into trying to at least explore the regulatory aspects of, sorry about that, I clicked locally but not remotely, regulatory aspects of BGPsec and routing security in general. There are some local entities here in Europe which are looking, regulation communication authorities which are looking into similar areas. So can I ask you, Hani, to tell something about that from your perspective?
Yeah, I'd actually like to start from a governmental point of view, wider than a regulator. So obviously BGP security is something that interests us, and there have been cases of BGP hijack, for example, in Finland. I think one funny one was where a Finnish network was hijacked. The traces led to the Black Sea, and who is information of the block that did the hijack said Cyberbunker 13 Samolia. That was a funny one. The other one was a company that had a big non-routed block that they only used for internal purposes, and that was obviously hijacked because it didn't have any entries. So those kinds of things do happen, and we are trying to monitor them. We do know that it's challenging. It's challenging for us. It's probably challenging for everyone, and we should do more. There are some plans on the way, but I hope to be able to talk about them at a later stage. So from a governmental point of view, we do understand that this is a problem, and there should be something that's done about it eventually. From a regulator point of view, things look a bit different. So I think in general, when looking at regulating internet, regulating IP traffic, we have been successful in parts, but there is, I don't know of anything that is related to BGP. We do have regulation that prohibits IP spoofing, as mentioned on the slide. We have been proud of having BGP 38 listed actually on the regulation in itself, but there is nothing specific to BGP as to date. As I said in my speech earlier, I'm not a part of the regulator crowd. I'm from the research side, but I'm not aware. Usually it's the case that many European countries are actually lagging behind on this. I'm not sure. If you know better, please do chip in. I did.
Yep, you went to.
I can share something about the situation in the Netherlands in terms of regulation and RPKI-based origin validation. The approach that the community came up with was to ask the government not to mandate any specific technology because the fear was that that might stifle innovation to some degree. But what did happen, there's purchasing recommendations in the Netherlands for governmental institutions, and RPKI was added to that list, and it's a apply this technology or explain why you're not using the technology. And this is a fairly nice light touch because it forces every governmental institution that is purchasing internet services to consider RPKI. And if they don't want to do it for one reason or another, that's great. They just need to document why not. But in practice, the result is, since so much of this is outsourced to commercial companies, that the governmental institutions ask their suppliers, hey, are you doing RPKI? If not, why not? And this has a nice trickle effect into the ecosystem. And I wanted to comment on the percentages on the slides. A little bit more than a third of the default free zone is covered by RPKI ROAS. That's great. But recent research by Kentic showed that more than half of the traffic, at least in North America, is flowing towards RPKI covered prefixes. So from a signing perspective, if you look at the absolute numbers, we're not halfway there yet, but if you look at traffic volumes, we're already past the half point. So I think that shows that RPKI has tremendous impact already today on the global routing table.
Yeah, you're probably right. It's probably reflected in these figures as well. These are not like gospel. I whipped them up in like 5 to 10 minutes, so they might take them with a grain of salt. But I think we have a lot of small providers. We have a lot of small ISPs, and that's why probably I think the major providers are doing well, and we could raise the bar if you would want us to. If you don't know about the regulation, how it's done in Finland, I'll explain to you that we want to do pretty much the similar thing to Netherlands. Obviously, Netherlands is a good example in this, and IPv6 and many other things. And we like to cooperate with the ISPs, with the subject that we regulate. So basically, I'm explain it to others in more than one occasion that our approach is, hey, you'd probably agree that this is a problem, and if so, please help us help you. Please, please tell me how you would like to be regulated, because in many cases we don't know the right solution that would fit ISPs, and they might have some solution but might have difficulties selling it to the management, and we can help there, and we've done that in the past. So this would be a great opportunity to cooperate on this front. And as far as governmental purchases, that's a good suggestion. Sorry, we are not in the right slot in the government to make that happen, at least very easily.
All right, thank you. Anyone from the audience, would you have anything to share on this topic from your perspective, your experiences from your local countries and policies that you're dealing with? Anyone? Well, if no, then let's go and try to deploy some of BGPsec. But for that, you need equipment. Alex, you wanted to ask? All right. So let's go and deploy some BGPsec. Apparently, for that, you need implementations. Today, the overall situation with implementations of BGPsec that what is available is predominantly in the open source domain or some internal implementations which are not necessarily publicly available. The availability of commercial equipment which supports BGPsec out of the box is virtually non-existent. Vendors are looking into that. What is available today at best is on a prototype level. And the functionality and the feature coverage varies a lot. That is something seen as a real limiting factor. In order to gain experience, you need to experiment with something. You need to explore how both the architectural aspects and the protocol itself and the scalability aspects, how they behave in a real deployment. And to an extent, we are getting into a rather closed loop. Commercial vendors are telling that they don't see sufficient interest from the community side, therefore they don't prioritize this in their roadmaps. And as a result, there are no implementations which you can get your hands on and experiment with and provide the feedback. Specifically, if we are looking in the context of the exchange operators, route server is certainly a place where BGPsec can start, and there are at least beginnings of the implementations that can support that, but that's not enough. You need support on the client side too, and that, as a rule, are commercial implementations, so you need both of them. We also need to do sufficient interoperability testing in order to understand how this works, what are other hidden problems in this. It's not enough to publish an RFC. It needs to be implemented and be available in shipping. Personally, I don't believe, and I'm talking to others who are looking into this topic, I don't believe that we will see global end-to-end deployment of BGPsec anytime soon, and anytime soon probably within the context of this decade. However, it's likely that BGPsec will start to be deployed in limited domains. And that will be end-to-end within a limited domain, for example, being an IX with its customers, or certain private peerings, or certain, say, portions of internal network infrastructure. And then those islands will have a tendency to interconnect, and this way we will get a partial global BGPsec coverage. Looking at the timelines, of course, making forecasts is a joy to do, especially looking backwards how they don't materialize. But it's not practical to expect widespread deployment of BGPsec, say, earlier than middle of this decade. Something probably starting from 2025, we might see better situation with commercial implementations, and this will provide for more practical experience with this architecture overall. You also need to take into account planning cycles, not only from a vendor side, but from the user base too. Network architectural aspects take time, and what can be architected right now will probably get deployed after several years. You need to account for many factors into that. This is not a fast process, but there are movements in the background. And therefore, well, maybe I'm too naive or too optimistic. I would expect that by the end of this decade, we will see a story repeating what happened with the origin validation over the past decade. It was slow to take off, but eventually now we have reasonably good coverage. And with that, I would be really interested in hearing the views from the vendors who are present here, vendors both from a commercial side of the house and from vendors from the open source community, what their views are on these topics. And I see somebody running to the microphone.
Could you also change that slide, please? Thanks.
Thanks a lot. Sorry about that.
So, Florian from Arista. I've done some internal digging, and the oldest artifacts I could find in our corporate groups whatsoever were from 2018. There seem to be some interest, and you mentioned it before, it's always for us about the interest from the customers, because it is a tremendous amount of work, and well, we're no Cisco, right? We don't have like 100,000 developers. I can only speak for myself here. So when we start prioritizing at that point in time still a draft and start implementing this feature, something else usually drops. So if you're interested in something like BGPsec, the best thing you can do is raise your interest with your account team, make them aware that this is important for you, and then we'll see where it goes. In the end, this is usually, from a vendor point of view, a combined effort. If we see a lot of interest, this does not necessarily mean we see a lot of dollars for it, but if we see a lot of customers wanting this, then it becomes interesting for us as well. The second thing is about performance. We're dealing with a lot of larger networks nowadays, and for them, like literally every CPU cycle counts. So from a performance perspective, BGPsec is a fairly expensive technology. It gives you additional security, but convergence on your IGP as well as your full table routes is crucial for them, because you don't want to actually black hole traffic, particularly in a tier 1 or large tier 2 network. So it is probably still something what people should look into, and from a routing security perspective, absolutely necessary. But now the magic comes up, it's sacrificing performance against security. This is how at least I could see it also with the threats and the customers I'm talking to. Thanks.
All right, thank you. Job, I know you are dealing with open source implementations. Do you have any view from that side?
Sure, but let me first react to what Florian shared with us. As we are moving from a plain text system, BGP4, towards a cryptographically secured system, BGPsec, it should be obvious to everybody that security indeed comes at a cost. If you hire a few bodyguards to protect yourself, they will want a salary, and there's a cost associated with security, always. Is the cost proper if you offset it against the gains? That is up to the community. I, for instance, envision that initial BGPsec deployments are not on the full routing table sessions, but for instance on the private peering sessions between Fastly and Amazon. The curious thing about such BGP sessions is that they carry incredible amounts of traffic, but fairly low BGP state. Each party is announcing a few hundred or a few thousand routes, not hundreds of thousands of routes. And if you want to secure the full routing table, the close to 1 million routes, I consider that a lower priority at this point in time than securing the private peering sessions. In general, people will set up private peering sessions because it matters to them to have a direct adjacency with this network. It could be for latency reasons, could be for performance reasons, could be economic reasons. And generally, private peering sessions carry a higher local preference than, say, your gateway of last resort, the transit provider. So all these interesting business-driven aspects actually help the case for BGPsec, especially at limited, when initial deployments are with limited capability. Limited capability meaning like, hey, we have a CPU, but it's not infinite how many cycles we can spend on it. But maybe the CPU cycles that can be spent are sufficient to help protect those high-value peering sessions. And to react to the open source aspect, as I am involved in OpenBGPD, I have a strong interest to find funding to help the OpenBSD project integrate cryptography and BGP routing. I think we as a project are uniquely suited to provide a production-grade implementation. We already have a BGP daemon that is part of the project. There already is an RPKI validator that is part of the project. So all components to move towards a BGPsec capable implementation are there. So I'm very excited to work on this and also with other vendors to ensure proper interoperability. But yeah, if you have spare money laying around, come talk to me, because at this point in time, the only obstacle is the ability to pay the salaries of the developers who will make this system.
All right, thank you. I see we have a question.
Yeah, so imagine this. I'm an African ISP from a poor country. I've just bought some MX 240 pre-used, or a couple of those, and it's got an old routing engine. I've got 3 transits which have very diverse C cables, so I've got that much money, but I'm not very well able to keep up with the world. Also, I have other priorities than to follow IETF standardization. So I heard about RPKI last month, looked at it, and noticed that this is something that I can just go sign on Afrinic's website a thing, and then it works for me, and my upstreams already do it the other direction for me. So that's sort of my level of knowledge. But suddenly, the world starts deploying BGPsec, like some big operators suddenly start signing the paths. And without me knowing really why, the memory usage on my router starts ballooning like crazy, and my routing engines are dying. I'll be very angry when I find the reason why they're dying. So this is going to be a PR issue. Before, routers ran out of memory because the table grew very fast, maybe every 5 years, but this might make it a lot worse.
So if your router does not support BGPsec, and this is negotiated as part of the session opening, the BGPsec attributes are not sent to you. So there will not be a memory increase for routers that are not BGPsec capable. I think that's the good news. But you're right to point out that there will be a long tail of institutions that rely on second-handed gear, and it might take some time before a technology like BGPsec becomes available to them. Perhaps a little bit of a flawed analogy, but I used to work at an IP transit provider that was using brocades to deliver service. This was PowerPC-based CPU architecture. And alongside various implementation bugs, such as if your SSH key was too large, the router would crash, at that time I could not envision doing any cryptographic operations on such devices. But Moore's law, to some degree, also applies to the routing engines, and there is a life cycle that is unstoppable. Many companies upgrade their gear every 5 to 6 years, and better CPUs are making it into the field. This is why I think BGPsec deployment should really be viewed as a 5 to 10 year project, because we are essentially just waiting for routing engines to be upgraded and to become sufficiently performant to support the BGPsec deployments that we envision. And on the other side, if the open source implementations like BERT and OpenBGPD and FRR routing support BGPsec, generally these are deployed on commodity servers. A lot of cloud providers are not actually restricted by what Cisco and Juniper can deliver, because they have moved onwards to deployments where the forwarding and the BGP route decision making are running on separate devices, offering more opportunities to just throw CPU horsepower at this problem and get the job done. So I'm far more optimistic about BGPsec deployment than I was a number of years ago, simply by having observed an increase in CPU cycles over the years.
And another aspect to add, BGPsec operation is not necessarily symmetric. You can sign what you originate, but you can offload verification to your upstreams. And the cost of processing signing versus verification is far more expensive. First thing, due to mathematics involved in the elliptic curve crypto system. The second thing, due to amount of entities that need to be checked. You sign only what you announce for your ASPAR, and you need to recursively verify everything that you receive from your upstreams. So this way, with your lower performance platform, you can sign what you originate, but then you trust your upstream that they will verify that for you. This might be a starting point. Then another aspect. There is a widely spread misconception about the limitations in the performance for the crypto performance. If you take contemporary hardware platforms, and contemporary I mean released within the last decade of time, more or less, they are limited not by the raw compute performance, they are limited by memory bandwidth. And yes, there are certain problems in BGPsec. Today, as it is specified, it is unfriendly to the current generation, the contemporary generation of compute platforms. Addressing those problems allows you for a substantial increase in performance. And this is not something unique to BGPsec as such. This is just a basics of high-performance software engineering, high-performance software and hardware interaction. And that needs to be taken into account. Looking into the direction of where the compute platforms are going, and they are going wider and not faster, if you want performance, you need to adjust to that. And this is exactly what will have to happen with BGPsec and other cryptographical systems. The other aspect, the other comment, kind of to summarize this, there is a practical limit of where you can push your platform. At some point in time, you need to acknowledge that this platform is no longer practically useful, and you need to deal with that. Right. Any other comments, any other feedback on this topic from the audience? Horror stories of running Exchange Fabric on some vendors' end-of-life equipment of 10 years ago. Anyone? No. Okay. Right.
I guess a good thing to also mention, right, is that outside of ASPA, right, there isn't really any better horse to bet on if you want to do BGP security, as we know today at least. Because I think everyone can agree, right, that BGP security, even though we have RPKI and we have all these things, it's still not done, right? Like, security is not done. So really, there is no other next step than this. Like, there is silly things with blockchain and these things that people are suggesting from time to time, but that is like real, actual implementable solutions. I think this is the only bet we have for now, unless we know any better. But I think everyone that is central in the internet working community believes that this is really the only improvement we have on the table outside of ASPA that is doable. So
yes, and the rather painful aspect is that we don't have first-hand practical experience, enough of the practical experience with that. We are just slowly gaining that, given the circumstances and given what is available. Give it a few years, we will have a much better view of what potential problems lie in this architecture, what potential attacks exist there. Today, we probably even don't understand the certain attack surface of BGPsec and BGP security in general, because we simply have too little of the exposure of these types of things with the community. And with wider deployment and experimentation, certainly there will be news, there will be attacks, there will be successful attacks, and we will learn many things related to that.
I want to add something about ASPA or ASPA and BGPsec because there's some confusion in the community that ASPA is maybe a replacement or a substitute for BGPsec. This is not the case. Both technologies solve different problems, and I think that we need both technologies. ASPA is what I describe as a solution to a business problem. It solves route leaks. And route leaks are somewhat of a subjective manner, because if you leak a full routing table to me, I might be like, hey, this is nice, this is free transit, and I don't see a problem with you leaking to me. On the other hand, what BGPsec helps solve is spoofing of the ASNs in the AS path. BGPsec does nothing against route leaks. If a route leak occurs and BGPsec is in use, you suffer from the leak, but at least everybody in the path was truthful about leaking. So you have full attribution who performed the leak and where it came from. So it's very important to distinguish these technologies. ASPA helps us publish desired routing policy conforming to our business requirements, and BGPsec helps keep everybody honest in the AS path. And this is why BGPsec does nothing for route leaks, it solves spoofing.
Right. And this gradually leads us to the end of our discussion. And that's an open discussion. Anything yet that you have on your mind related to the topic and specifically of BGPsec and routing security in general. So comments, questions, feedback, gifts, anything else?
So I'm hoping someone will have some actual constructive comments as well, but I just wanted to mention, since we have been having these seminars here in Tampere for a long time, I just looked back at our programs of our old events, and I found a presentation on BGPsec from 2011. So we've been talking about this before. Of course, the angle back then was different, and also the reason, because I think it was the same event where we talked about RPKI for the first time. And as I think Job said it, I was also doing some other things there, wasn't paying attention. We need both RPKI and we need BGPsec. But in order for BGPsec to have a foundation, we needed RPKI first. So when we talked about both of the technologies in 2011, RPKI was the one that actually started getting very, very slowly deployed. And now we are sort of in the same situation with BGPsec, because it's the next, I see it as the next logical step. I'm not sure if it's technologically the best way to, solve the problem. And this is exactly why I think open discussion is needed. Many of the alternatives involve blockchains because it's
Go wash your mouth.
And I don't think that is a good technical solution for this particular problem either. But we need to find one. I think that's...
I'm glad somebody mentioned blockchain. My bingo card is now full.
And you're just glad it wasn't you.
So to provide some historical context to why is BGPsec starting now and not, say, 10 years ago when the first drafts started being developed, the timeline is actually far more horrible. It was in 2003 that RFC 3779 defined how to put AS identifiers and IP blocks into X509 certificates. And that was the foundation towards the RPKI system, which enabled us to do origin validation. And I think it's really good to keep in mind that RPKI is a cryptographic and distributed database in which we can publish things. It is a distributed database on which we can run multiple applications. Origin validation was the first application that we managed to successfully deploy on a global scale. What was challenging in the origin validation deployment process was that not only did we need to teach BGP routers how to do a fairly simple integer comparison between a ROA and a BGP route announcement, but also the RERs needed to build signing infrastructure. Like RIPE NCC had to design a RPKI web dashboard, RPKI validators needed to be written and deployed. But all that infrastructure is now in place. And BGPsec, just like origin validation, is a RPKI-based technology. So the BGPsec public keys are published through the same system as you publish ROAS. So a lot of work that was put into origin validation is now being reused for BGPsec. And the same goes for ASPA. ASPA is another application built on top of the RPKI distributed database. And again, we get to recycle all these components that were painstakingly built over the years. So I think that it's good to separate out in our minds. Origin validation is an RPKI-based application. BGPsec is an RPKI-based application, as is ASPA. And I bet there will be future RPKI-based applications because this cryptographic infrastructure is super efficient. We've managed to make it fairly reliable, and it took us maybe 20 years to get here, but we are here.
And it seems we're recycling the same people in the same companies again to kind of make this going. So, yeah.
Right. And BGPsec as such is not a new thing in routing security, and particularly in BGP context. There was secure origin BGP, SBGP, some of experimentations with extending the transport security and things like that. Now BGPsec of 2011, while fundamentally still doing the same thing, it differs quite radically. One of the reasons why BGPsec didn't see practical deployment at that time was the use of RSA crypto system. And that one is really too resource costly for practical deployment in outside, say, of experimental environments. Move to elliptic curves crypto system allowed for substantial reduction of that cost and also changed the balance of signing versus verification. That doesn't mean that the current version of BGPsec is perfect. There are things that need to be improved there and fixed, and with deployment we'll certainly find other things. But at least now it is getting closer to be practically deployable.
So as it stands, I am the only person on the planet publishing BGPsec keys for my private AS number, personal AS number. And I hope that more people will start joining this effort and publish keys as well, because it's kind of hard to do eBGP with just yourself.
Very exclusive club.
Right. Any other comments on this topic? What would your plans look like? Do you see this as something of potential interest area, or would you be looking deeper into this? Do you have any plans in your environments for potential use of say, path validation type of solutions? Yeah, please.
So one of the things I just looked at is Bird. There's a BGPsec enabled Bird build somewhere in the internet, but it's only 1.6.0, so that might be something nice to work on. At least that would get some personal networks participating.
Yes, implementations, as we have been discussing previously, that's one of the pain points. And there are fragments, various fragments, libraries, experimentals, and also one word of caution, there are implementations outside in the field which are outright dangerous. which will leak private keys if you are not careful enough with them. Therefore, yes, as anything related to cryptographical things, it might get dangerous if that is used improperly. But certainly we have many things to improve on this topic. Open source and then commercial implementations at this time are a pain point, yes.
I can make a quick comment as well from Amazon's point of view. I mean, I think this is a very interesting technology, right? And we are quite fluent in RPKI technology already, and you know, we are targets of attacks basically every day, a couple of times every day actually. So we are very well invested in making this a better thing, and so far we see this as, together with USPA, as you know, the horses to bet on this in this race, right? So. Maybe we will not be number 2 in publishing keys, but maybe number 3. We'll see. But obviously, there is still a lot of work that needs to be done. But we are fairly well set up to be able to do some of this, since we also run disaggregated architectures where we do a lot of the BGP routing decisions on not a hardware-style router. We do it with software-type routers, so which makes it fairly pluggable for us to start building this. And also, just as Job said, right, that there is a couple of, you know, peering relationships between these big companies that are very valuable, and that also, you know, with fairly small implementation, you get a massive benefit, because there is peering relationships we have which consist of hundreds of links to the same ISP, and if we can start running BGPsec on those, that can help us quite a lot on a like global scheme of things. So.
All right. I think we discussed quite many of the interesting topics here, but there's one other very interesting topic awaits all of us. That means the coffee break.
Yeah. So thank you. Give a big hand to all the panelists.
Thank you.